I've heard that when the Milky Way and Andromeda galaxies collide here in a few years, that star collisions will actually be really rare because on the grand scale of things, the stars are like little pinpoint particles separated by vast distances, even though in reality a star is like a million times larger than the planet Earth. But there's just so much distance between them that collisions will be rare. So in the downtown area, the center of the galaxy, the stars are pretty dense. There's going to be a few more star collisions possibly. And then also when the two galaxies collide, I don't know if that'll be more of a glancing blow where they just mostly orbit each other and get their structures all changed around, or if you could end up getting a direct collision where the black holes merge. So that's just some stuff to think about. But I was wondering how far apart the stars would be if we could scale them down, scale the stars down and the distances down to something here on Earth, so we could get somewhat of a tangible example. So I'm going to go with Proxima Centauri, the nearest star system, about 4 light years away. And if you want to go toward the center of the galaxy where stars are a lot more dense, then you can use different numbers. So 4 light years away, I just said 4 years. A year is 365 days, a day is 24 hours, hour 60 minutes, 1 minute 60 seconds, 1 second is 300 million meters. Because light travels 300 million meters per second, 1,000 meters gives you a kilometer. So years cancel, days, hours, minutes, seconds all cancel. We're just left with kilometers right here. And that will be 37.8 trillion kilometers, or 3.8 times 10 to the 13th kilometers is how far away the nearest star system is from us. Here's how we can scale our numbers up and down. We can take big divided by small to equal a scalar quantity. Some trivia is that scalar as an AR. So we can take the number, 4, and we can scale it up to 8 or scale it down to 2 by either doubling it or cutting it in half. If it's scalar with an ER, that's a dental tool used to scrape off plaque or something. So instead of big and small, I'll say star distance divided by the sun diameter. So we have something really big divided by something really small, relatively speaking. That'll equal our scalar quantity. So now what we can do is take this sun diameter times the scalar quantity, and that'll give us our distance to the star. And vice versa, we got our distance to the star. We can divide that by the scalar quantity right there and get the sun's diameter. Let's take the space between the stars, divide that by the sun's diameter, and we will get 27 million, or 2.7 times 10 to the 7th. And notice on this, the kilometers will cancel out here. And when you take kilometer divided by kilometer, so we just end up with a scalar quantity right there. So what that means is we can take the sun's diameter, multiply it by that, and we'll get the distance to the nearest star system. And it looks like this: diameter of the sun times that number gives you the distance to the star system. Or you can take that distance, divide it, let's see what I say, take the distance to the star, divide it by that quantity right there, and you'll get the diameter of the sun. So what's fun about this, you could start with the diameter of the sun and say that it's 1 centimeter or 1 mile or whatever you want to call it. Or you can start with the distance to the nearest star and call it 1 centimeter or 1 foot or 1 mile, and then find out how big the sun would appear at that scale. I'm going to call the sun 1 centimeter, so 0.01 meters. Multiply that by our scalar quantity right there. So if the sun is 1 centimeter in diameter, the distance to the nearest star will be that many meters. Divide by 1,000, 270 kilometers. So what I said right here is if the sun is 1 centimeter, the distance to the nearest star will be 270 kilometers. We can turn those into American units if we want to. 1 centimeter, 2.54 centimeters gives you an inch. Centimeters cancel. You get 0.4 inches. So just right under a half an inch. So if the sun is about just under a half an inch, we can take that 270 kilometers, 1.61 kilometers per mile, gives you 168 miles. So if the sun's right about a half an inch, then the nearest star system will be 168 miles away. And I'm going to leave the numbers just like that. I'm not going to compare the distances between two cities such as the distance between Minneapolis and Des Moines, because unless you're from that area or you happen to look at a map, that distance really won't mean anything to you. So I think it's more interesting and useful just to leave the numbers like this, say 168 miles or 270 kilometers, and you can think about how far away that is from you. It's also fun to think about if you had a little marble that was a half an inch somewhere over an area that was 168 miles. Think of how hard it would be to find that little marble. It'd be impossible. So at least for us out here in the suburbs of the galaxy, then yeah, star collisions will be pretty uncommon.